point of inflection. A point on the graph where a tangent line exists and where the concavity changes is called a point of inflection. This is where the graph becomes from concave down to concave up, or concave up to concave down. So what this means is that you need to have two things to be a point of inflection. The first is you have to have a tangent line. The second is the concavity is going to change. So for a tangent line to exist, we also need to know that the function is differentiable and continuous. So in essence, the point of inflection is just where the second derivative changes from negative to positive or positive to negative. So in example 3, we're going to determine all points of inflection on the graph y equals e to the power of negative x squared. If we look at the graph of y equals e to the negative x squared, it looks like this. And we've worked with this function before. So we know that right here the function's increasing, and here the function's decreasing. And if we look at the tangent line, we can see that the tangent line exists everywhere. And so we know that if it's concave up, then the tangent line is going to be increasing. This does not mean that the tangent line has to be positive or negative. It means that it has to be increasing. So right here, you can see that the slope of the tangent line is becoming larger. So this is concave up. And as we move on, right here, the slope of the tangent line becomes smaller until the slope is 0. And here, the slope of the tangent line is becoming more negative. So it's concave down. But here, it becomes more positive, so it's concave up. So if I were to highlight these points, this would be my guesses for where the tangent line changes from increasing to decreasing. So you can see right here, it's going up, and then it starts to slope back down. Very similarly, right here, the tangent line is decreasing in its slope. It's becoming more negative, and here it becomes more positive or less negative. Another thing we can look at is the second derivative. So this is a graph of the second derivative, and you can see that if I get this vertical line right here, at this point, this is where the second derivative goes from being positive to negative. So this is where our inflection point is going to be. So this is what it means graphically for there to be an inflection point. Now let's look at it algebraically and actually determine the point of inflection. So what we need to do then is the first thing is to take the second derivative. So here we go. I want you to go ahead right now and try to take the second derivative on your own. So pause the video, take a second, and determine the second derivative. All right, here we go. So we have y is equal to e to the negative x squared. So we get that y prime is equal to, well, the derivative of e is just itself, so e to the negative x squared, times the derivative of the exponent. So you get y prime is equal to e to the negative x squared times a negative 2x. So this is going to be y prime is equal to negative 2x e to the negative x squared. That's the first derivative. Now what we have to do is take the second derivative. So y double prime is going to be, we need to use the product rule. So you get negative 2 e to the negative x squared plus negative 2x times e to the negative x squared times a negative 2x. This is just taking the derivative of this piece again. This is this. So we get the second derivative is equal to negative 2e negative x squared plus 4x squared e to the negative x squared. Now what we need to do is set it equal to 0. So you get that 0 is equal to, and I'm going to factor out my e to the negative x squared. Negative 2 plus 4x squared. I'm going to go ahead and I'm going to factor out a 2 as well. So 2e to the negative x squared would be 2x squared minus 1. And now we need to set that equal to 0 and solve. Now notice that this can never be 0. This is because this piece right here is 2 divided by e to the x squared, and you can never make the denominator 0. So then we just need to focus on this. So you get 0 is equal to 2x squared minus 1. So 2x squared equals 1. X squared is equal to 1/2. So x is equal to plus or minus 1 over radical 2. So those are going to be our points of inflection. So now what we're going to do is make a sign chart. And again, remember on the AP test, this does not count as proof. We need to select our points, which is going to be negative 1 over radical 2 and 1 over radical 2. So now we need to determine if the second derivative is positive or negative in these intervals. So to do that, we pick some points in between. So I'm going to choose negative 1, 0, and 1. So now what we have to do is plug those into the second derivative. So you get f double prime of negative 1 is equal to e to the power of negative 1 squared times negative 2 plus 4 to the negative 1 squared. So this is going to be e to the negative 1 times negative 2 minus 4, or plus 4. So this is 2 divided by e, which I don't know what this actually is, but it is positive. And that's what's most important, is that it comes out to be positive. So we put a plus right here and an arrow going up. Then what we need to do is do the same thing for 0. F double prime of 0 is going to be e to the 0 times negative 2 plus 4 times 0. This is positive. This is going to be negative. So the whole thing comes out negative. So this is going to be going down. And we got to do the same thing for 1. So f double prime of 1 is going to be equal to e to the negative 1 squared times negative 2 plus 4, 1 squared. This is positive. This is positive. So the whole thing comes out positive. So we can see that right here, at negative 1 divided by radical 2, you have an inflection point, as well as 1 divided by radical 2. Now what we need to do is find the y value of those inflection points. So you find f of negative 1 divided by radical 2, which is going to be e to the power of negative, parenthesis, negative 1 divided by radical 2 squared, which gives you e to the negative 1/2, which is equal to 1 over e to the 1/2. Let me simplify it a little more. You can put that in a calculator and solve, but that's okay. We don't need to. Leaving it like that's just fine. If the problem asks you to round or truncate, then you're going to need to. And we're going to do the same thing for 1/2. we get e to the power of negative 1 over radical 2 squared, which is e to the negative 1/2, which is equal to 1 over radical e. You'll notice that these y values are exactly the same. If we looked back at the graph, let's turn off some of this, we can notice our points of inflection are right here and right here, which are the same. So now we have our x values, we have our y values, now we just need to be able to write our answer. So to write our answer, we have to notice something. Since the sine of y double prime changes at negative 1 divided by radical 2 and 1 divided by radical 2, the points of inflection are going to be negative 1 over radical 2, comma 1 over radical e, and 1 over radical 2, comma 1 over radical e. And this is what the answer wants. I'm not asking where it's concave up or concave down. I'm just asking for the points of inflection. And that's it.